Hello all, today in this video I am going to provide details regarding an demo uh, for crop yield detection, and previously we have worked with some algorithms, and now in this code we are going to work with an gradient boosting regression algorithm other than classification algorithm. Since our data set is having both categorical and numerical values, we are moving with the regression algorithms rather than classification algorithms, because when compared to this classification algorithm, regression algorithm will provide better results when we are working with both categorical and numerical data set. This data set I downloaded from Kaggle, and for that initially we are importing the libraries which we are needed, and then this is the data set which we are having. So in this, the yield we will be using as the y variable, and apart from the yield, every variables is be used as the x variable. And here we are going to work with preprocessing by using the label encoder function, and also we are displaying the heat map of the data set. And then we are making to group our data set into crop, production and area. By this we are confirming that our data set is having more than 50 crop types, you can see over here. And then we are declaring the x variable and the y variable. As I said, the x variable we are dropping the yield variable, and everything other than yield is chosen as the x variable, and for the y variable only the yield is chosen as the y variable. And then we are getting the dummies, we're checking with is there any dummies in the x variable, and then we are splitting our data into x train, x test, y train and y test by using the train test split function, and the test size as 20%, that is 20% will be taken for testing and the remaining 80% will be taken for training. And then the random state we have declared as 1. So in the previous code itself, we have previous video itself, we have worked with linear regression, and we got an accuracy of 83.94 with the train, and test accuracy as 85.803. And in the previous video we have also worked with decision tree, for which the training accuracy is 100 and testing accuracy is 93. Also we worked with random forest, which training accuracy is 99.44 and testing accuracy is 95.29. In this code we are going to work with the gradient boost. So for that we are importing the library which is needed for gradient boosting, and then declaring the gradient boosting for regressor function by using the n underscore estimators. Estimators numbers we have declared as 100 and learning rate as 0.1. This one you can change as per your wish. And then we are training our model by using the fit function and also the training variables. And then we are testing our model by using the predict function and the testing variables. And then we are declaring the values for accuracy, mean square error and R2 square, and then we are going to display the value of the training accuracy and testing accuracy of gradient boost regression algorithm. By this we are getting that the gradient boost algorithm is getting 99.7% training accuracy and 97.01 testing accuracy. Previously in the previous code we would have compared that the random forest is providing better accuracy when compared to the other algorithms. Now we are also as same like in the previous figure, we are making a comparison with the four algorithm. For that we are making a loop, for loop. Within the for loop we are calling the testing function, training function, testing function, and also the accuracy, mean square error and R2 score. And then we are also going to display the accuracy of every model in the same uh, uh, cell. And then we are making to display them in a table. In the table we are getting the four algorithms we are worked with. In this which is the algorithm is providing better results will be highlighted in green, since we have called over here. And then which algorithm is having the least measure will be highlighted in red. All those details we have made here to highlight. So that is done here. So by this really we can make an conclusion that linear regression is providing least result when comparing to gradient boost, random forest, and decision tree. From this, random forest is providing better results, and model other than random forest is a gradient boost is providing the better results. A model other than gradient that is lower to gradient boost is random forest, lower to random forest is decision tree, and decision tree is providing the least result. So this is the code for gradient boost, and also we have made an comparison. In the next video we will be working with XGBoost algorithm. So if you are interested in knowing to some other demo video means, please let us know in the comment box. If you are aware of it means, we will definitely make a video regarding it. Thank you.